Active suspension is not anything new. It actually has been around since the first production vehicle it was put on was a Citroën. I forget the model of the Citroën, but it's a French car, and it used bladders that had a divider inside, and it used a hydraulic fluid, and it had an air pocket in there. So the hydraulic fluid would move through the system as the vehicle encountered different irregularities in the road surface or when turning, and that fluid pressure would act through hydraulic lines to opposing corners, and the air pressure in the opposing bladder would resist that fluid. And this would make the vehicle handle much more smoothly on the road surface. Problem is, servicing the system is, for one, a rare system for the vehicle, and when you see those vehicles nowadays, they're usually sitting on collapsed suspension. The route that most manufacturers took to provide an active suspension system revolved around using air compressors and air springs. By using air compressors and air springs coupled with height sensors, a module, and an air compressor, the air system could then sense when the system was too low in one area and apply air pressure to those air springs and raise that up. These were the early designs, commonly found on the early 2000s Ford Expeditions and Lincoln Navigators. Common problem with this, as we went over in another topic, was the air springs themselves. The rubber breaks down and can start becoming perforated and allowing air pressure to escape from the air spring assembly itself. What will happen over time is the compressor will struggle to keep up with the air loss in the system, and eventually the compressor will burn out, to which the customer will do their own research a lot of the times and find out that their compressor is not working. And they will ask, as they have many times, can you replace the compressor on my air system? Replacing the air compressor on a system that's leaking and led to the compressor failure isn't going to fix the problem. It's fixing the symptom, but it's not addressing the root cause as to why that system failed. Usually these systems need to be completely replaced, air springs, compressor, dryer, sometimes the lines, and it's usually available in a kit. Yes, you can replace them. Yes, it's expensive. As an alternative solution to the problem, retrofit kits are available to restore the vehicle to a mechanical suspension system. This is often going to be less expensive than replacing all the air components, the lines, the compressor, and the dryer, and the driver gets the road feel of a normal vehicle with a standard suspension system. The drawback is it no longer has self-leveling capabilities. Now, going beyond self-leveling, active suspension systems take it a step further. Rather than just being adaptive, they are actively monitoring and adjusting how the vehicle drives and handles while it's occurring. An active suspension system can be set to different settings to provide a more comfortable or a more sporty feel of the vehicle. This can be done through air systems, and it can also be done through hydraulic. The more advanced type is through an electromagnetic fluid, where there are ferrous materials and particles suspended throughout a fluid. And in the suspension system, when the fluid passes through an orifice, there is a coil around that fluid passage that allows the fluid to pass through. As the amperage increases, the ferrous particles in the fluid align with the magnetic field of the coil and will resist movement through that orifice. The orifice itself hasn't changed size, but the application of amperage to the coil, the electromagnetic coil, producing the electromagnetic fields will cause the fluid to resist going through that until it passes through. This has a couple functions. This means that the fluid can be slowed down to stiffen the ride or increase the dampening of a component, and the system can then act as a sway bar and help stabilize the system during the active body control movement of the system. These are going to be controlled by a module. Now, the module receives inputs and outputs commands. So based off of the sensors in the system, they will input to to the control module what is happening in the suspension, and the control module output commands for different parts of the circuit to activate versus others. Other systems can have a tri-state damper. There can be a single state damper, which is this. This is a single state damper. There's no difference in how much this absorbs and how much this regulates the flow of fluid through the orifice or through the valving assembly. A bi-state damper will have a passage on one orientation, and then that passage can be clocked 90 degrees to another orientation that allows more fluid to flow through. What that will likely look like is something on top that will rotate the internal valving of the shock absorber or the dampener. Depending on the driver's input, they can select different settings on the suspension. Perhaps it'll be sport and comfort, or normal and sport, normal and comfort. Depending on what the vehicle manufacturer builds into the system will depend on what the driver is able to select. Now, these are not a structural component of the suspension, they only dampen. Same applies to bi-state and tri-state dampers. What I mean by bi-state dampers is that there are two modes of dampening that can occur within one assembly. So if the setting on the suspension system is tuned to sport suspension, does that mean it's going to restrict flow from one end to the other end of the assembly and be stiffer, or is it going to allow more flow and be softer? Well, a sport suspension is going to be stiffer, so it's likely going to rotate that valve assembly to the stiff setting. This is the same thing for tri-state dampers, where one direction it may restrict, another direction it may open up another set of orifices, and then a third setting may be somewhere in the middle or restrict more or allow more flow. So by changing the position, by rotating the internal piece, likely through the top of the assembly, down inside, that valve is actually changing position to allow more or less fluid to flow through the orifices. Again, this is going to have to be done electronically through the module and the command and output command based off of inputs. Input in this case being driver clicking a switch for a certain setting is the input to the active suspension control module, and then the control module determines the output going to each of the dampers to clock which direction to allow fluid flow for that given setting. Based on these concepts, a manufacturer may have more or fewer inputs to their control module depending on the system. There are some aftermarket shock assemblies or shock dampeners that are available on the market that have a valve on the side that you can clock to different positions. This would be, let's say, something that you might put on a four-wheel drive truck that doesn't have any type of active suspension on it, to where you can manually adjust the dampening characteristic of each of the shock assemblies to help tune the ride of the vehicle to your preference. Other vehicles like the late 90s Mercedes S-Class with active body control uses about, with the active suspension control, uses about 13 sensors as inputs to the control module. And when the system is serviced, it requires a recalibration for the system in order to establish its 0 point and the extreme movements of it. You may have to do a similar procedure on a vehicle. On the Mercedes, it's called the rodeo test, and it actually rocks the car around its axis in the center, and they call it the rodeo test. There are some PCC fleet vehicles that have air suspension and automatic suspension for testing. I don't have any here for any examples to use for this lecture, but I just wanted to discuss a few of the topics. Typically what you're going to find on a system like this is a control module for the system. If it's a less intelligent system, let's say we're dealing with something like the active ride control for air suspension for the height adjusting system like this, there will usually be an electronic connector on the end of the dampener. There may be height sensors. Height sensors will be separate from other components of the suspension system, and they may have links with pivoting arms, and they move with the suspension movement. So as those arms detect a change in height, they're going to output their signal to the control module, and the control module is going to determine if there's any action that needs to be taken, whether that's providing amperage to a flow control valve within a electromagnetic damper, provide air pressure for an air suspension system, or clock a valve assembly in a bi or tri-state damper. So these are some things that you will come across at some point on the school vehicles and in the industry. It's important to know whether or not a vehicle is equipped with an active ride suspension system. If it is equipped and you don't follow correct procedures when lifting or servicing of the components, damage can occur. And sometimes on an air suspension system, if you raise the vehicle, it will inflate the airbags, it'll inflate the air springs, and then once the vehicle is lowered back down, due to the air pressure in the springs plus the vehicle weight on the system, will cause the air springs to explode or fail. So understanding what these systems are, where to look for them, what types of vehicles they might be on, and based off of the identifying characteristics, knowing ahead of time will help you service these systems. Servicing them correctly is going to prevent damage and failure of components that is not needed. Active suspension systems often use the same types of sensors that are used for other systems. This is where we have overlapping systems. It may use vehicle speed, yaw rate sensor, lateral accelerometer, steering wheel position, steering wheel force, and other sensors that input to multiple systems, and oftentimes these can be housed in the same control module. So active suspension systems can also use the same inputs as vehicle stability control, electronic braking control, and sometimes traction control. We'll go into the operation of some more of these other systems and some of the inputs that the module is going to use that will often be used for multiple stability systems, including suspension, braking, steering, and stability. This was a short one. I'll catch you on the next one. Thank you.